Hello, this is Paul Harris from PH Tutoring, and this is the latest video on quadratic equations. We're going to be looking at quadratic graphs today. So far, in the series, we have started off with what is a quadratic equation. We then went looking at how to factorize quadratic equations when a is equal to 1, then how to factorize quadratic equations when a is not 1. Then we looked at how to solve quadratic equations by factorizing. We looked at the quadratic formula, and we looked at completing the square, and now we're on quadratic graphs. What I'm going to do for this lesson is I'm going to be using this program called Desmos, which is a free bit of online software. And we're going to have a little play with how with this software, so we can see what we can learn from quadratic graphs, and also I'll show you how to use the software a little bit as well. So what I've done is I've taken one of the equations from our previous video, x squared plus 8x plus 6, rather than saying it's equal to 0, I've said it's equal to y. And I end up with this graph here. Now, I'm going to assume that you are familiar with how algebraic graphs work. So, for example, you would have looked at graphs of straight lines, and if you're unfamiliar with that, I would make sure that I would probably give this quick video a go, but I would suggest that you get familiar with that first if you find this video a bit tricky. Another thing that might hinder your understanding of this video is transformations of functions, or transformations of graphs, or transformations of graphs of functions. All the three different ways of referring to the same topic. So let's jump in a bit. We're going to imagine. Well, let's just remind ourselves that all quadratic. Well, okay, where shall I start from there? So all quadratic expressions are in the form of ax squared plus bx plus c. And usually we are putting them as equal to 0, but what we're going to be doing here is just saying that y is equal to all of that. So in other words, whatever our value for x is, our y value can be calculated by using this expression. So whatever the value for x is, y is going to be equal to the square of the value for x multiplied by 8. Start that sentence again. Y is equal to the square of whatever x is plus 8 times whatever x is plus 6. And if you did that, you'd get whatever y is. Okay. So we're going to look at, when we are sketching these graphs, we want to notice the y intercept, the x intercepts, and on Desmos you can lock those values by just clicking them. You can also find the value of anything else, but you can't lock them. Okay, so we have here the y-intercept, the two x-intercepts, and the minimum point. So this is the minimum. This is the minimum point. Okay. Now we know that this example here can be rewritten in this format. So it could be written as y is equal to, in brackets, x plus 4 all squared minus 10. And because now we only see one graph, it's because they're over the top of one another, because they are identical to one another. So these two expressions are the same, and so the graph could be also written as that. Now, Mario keeps losing connection. So what I want you to notice then is, by this format, that the minimum point is in fact this value here, right? So if I were to, maybe I will actually just take a screenshot of that. Let's get rid of that one now. And we will, I think I will, I think I'll just copy this from up here. Yeah, I'm going to copy the whole lot. Okay. So we've got some different versions of the equation. I'll put it for when it's equal to 0 in this case, but the point is, so maybe just shuffle it down and get a bit for a moment. What I've just plotted there is, as it says, as you can see, y squared plus 8x plus 6. I've also plotted y is equal to x plus 4 all squared minus 10, and as you can see, they're both the same, and that's because one is just a different version of the other. So we want to notice something about this, and that is that the 4, I'm going to have to use some lots of different colors here. Ignore any color coding from previous videos because this could confuse you otherwise, but I'm going to just highlight that 4, then highlight this 4. And I'm going to highlight this negative 10 and highlight that negative 10. And then I think I'm also going to highlight on the other version this 6. Okay, maybe I won't do that one just yet. So just look at this. So we know, we could rewrite, I think I need a format to demonstrate that. So symbols to represent the 4 and the negative 10. Okay, I'm going to use P and Q. I saw something using P and Q somewhere, so let's use that. So if we're starting off with A is equal to 1. So yeah, let's get rid of that A for the moment then. So we can say that that is the same as x plus p all squared minus 10, and so that would be our 4, and that would be the negative 10. Now these, as you can see, that this is being used to calculate the minimum point. So this is the negative of the x coordinate of the minimum point, and this is just the y coordinate. And so basically, in general, we can say the minimum point. This is also called the turning point. The reason why it's called the turning point is because it goes down, then it turns around and goes back up. And it's the reason, rather than call it a minimum point, is because you can have an inverted. So, for example, if I had, let's turn that off. If I had it like that, then it's flipped upside down, and then it would be a maximum point. So we just generally refer to it as the turning point as opposed to the minimum point. But if you've said minimum point, there's nothing wrong with that. I don't think you just it's just to know that the normal way of doing it is writing the turning point. So let's write turning point equals, and it's going to be negative p, and then just Oh, well, oh dear. So I'm doing a general formula, aren't I? Okay. So it's negative P and then Q. So that's the turning point. So you can use the completing the square, yes, to solve the equation, but it's more often used to find the turning point of the equation. If we look at a different one, our other one that we did, where we had a not equal to 1, we'll see how that works out. So we'll put y is equal to, and we'll write out the original format, 5x squared plus 2x minus 8. It's more squashed than the previous one, and that's because of this 5x squared. So you can imagine if I did it 6x squared, it's squashed even more. If for 2x squared, it's less squashed. So 5x squared. So if we zoom in, we can see that it's negative 2, negative 8.2. So it actually it ends up being the same sort of thing. So only before, when we had x plus p all squared plus q, we didn't have something on the outside. So we need something else, don't we? P, Q, R, I don't know. Or what's before O, P, Q? We can't use an O because it looks like a 0. What do people tend to use? Let's see. I'm just going to use R. It doesn't really matter. And looking around on the internet, people use a variety of different things. So being as I've used P and Q there, so we can write ax squared plus bx plus c. We could write that it could be, it would, no, let's say it's equal. It's going to be equal to r multiplied by x plus p all squared plus q. So like before, we can say that the q is that number there. Highlight that in blue, and the p could be there. Perhaps we'll highlight the r in yellow. And so in our example here, the r is 5, the p is 1.5, and the q is going to be negative 8.5. And before the turning point, in the case where a is 1, the turning point was negative p and then q. And what about here? Well, the turning point is negative 0.2, and it's the same thing. So the turning point is still the same. Turning point equals negative p. I might as well, I can just copy all of this, can't I? Okay, I think I'll just also copy this. Just copy the whole thing and put that onto the board about quadratic graphs. Right, so the turning point still ends up being minus PQ. Now, I should probably make it clear here that there is a potential for a fair bit of confusion, because the formatting that I've chosen is to put a plus and a plus here, which means that the coordinates end up being minus P of the turning point, minus P and then Q. But other people might write a negative and a negative, or negative and a positive, or positive and negative, and it all changes whether or not you put negative p and q there. So I don't want to spend too much more of the video talking about that, but just be aware of that, and I hope you can see how it could be potentially confusing. Right, so that's the turning point. Now, so we use completing the square to find the turning point. What about the other features of these graphs? The other feature is that, actually, I think I want to look at this might just be quite a long video in the end. So, yeah, the other feature, let's go back to our first example. So x squared plus 8x plus 6. So there's, actually, I think I want to choose a whole other one. Let's start off with a fairly basic one of the first ones that we did when we factorized it. We're going to do this one here. So x squared plus x minus 6. Right. Okay. And go back to our frame down here. Let's make that small, put that there. I'm going to take all of the points on this graph now. I'm also going to show you how you can change the dimensions of this. Yeah, so we click on this and I can change the range of the x-axes. So you can see that if I just limited it to -5 to +5, I can see more of what I'm trying to see. It spreads it out a bit more. Okay, and I could change the y value as well now, the range of the y value. So I could maybe go from, let's say, -8. Oh, wait a second, what? No, let's try that again. -8 up to maybe 2. Yeah, that looks fine, I think. Okay, and I'm going to just write the equation over here. So y is equal to x squared plus x minus 6, and I'm going to hide it there, and then I'm going to highlight the different features. So we've got the x-intercepts, the minimum point, and the y-intercept, and then I'm going to take a screenshot of that. Right, so here are the key points of that graph. And I'm going to write that into the different formats. So I'm going to complete the square, and I'm also going to factorize it. Okay, so we've got y is equal to x squared plus x minus 6. I'm not going to go through factorizing and complete the square, because otherwise the video will get really long. But there's a previous video on that. And so I've plotted them all onto the graph, and you can see they're all over the top of one another, which shows that they are identical equations, because when you put y is equal to all that, you just get the same graph. So we have the format y equals x squared plus 6 minus y equals x squared plus x minus 6. You also have y is equal to x plus a half all squared minus 6.25. And then we have the factorized version, y is equal to x plus 3 all multiplied by x minus 2. Yeah, so this is yeah, so these are all the different formats. So let's just look at some of these different points which we've got there. Well, the x-intercepts are going to be these values here. It's going to be the solutions to when, if we imagine that y is equal to 0, well, that is the x-axis, right? So at the point of the x-axis, as you can see, y is equal to 0. So this would be the solution as if the equation said y as if the equation said x plus 3 minus 2 is equal to 0, because that is when y is equal to 0. And we solve, and when we do that, we know that as we did in the factorizing, we find that x would be equal to negative 3 or x is equal to 2, and therefore that's where the x-intercepts are. We looked already about the minimum point, and then finally there's the y-intercept, which is minus 6. The y-intercept is when x is equal to 0. And so for this format, we look at the top equation, and we imagine, well, what would y be when x is equal to 0? It would be equal to 0 squared plus 0 minus 6, so therefore minus 6. So in summary, we have the same as before. We've talked about, I just talked about a moment ago. That's going to be the minimum point. The x coordinate of the minimum point is negative of a half. Hang on a second. I highlighted it differently, didn't I? I highlighted it like that. Yeah. And then the y coordinate of the minimum, or the turning point, is all of this. The the y-intercept. That's just going to be this one here. Is the negative 6, and the x-intercept would be the solution as if y is equal to 0. So it ends up being the solutions to the problem if y is equal to 0. So it's the negative of that, because you always have to take it away from. Well, maybe I just say that these are the solutions when, for any equation, ax squared plus bx plus c is equal to 0. When you solve that and find out what x is, that's what these x coordinates are. Okay, the video is going quite long, but I do want to, and you just switch off now if you feel like you've learned enough. But there is something else I wanted to talk about going back to the completing the square. Oh, maybe I'll put that in the next video then. So the next video is going to be a little bit of continuation of the quadratic graphs, but specifically talking about the turning point. And I'm going to link it to graphs of functions, transformations of functions.